So yes, hello everyone, it's me Abhay and this is a video editorial for the Global Round 15. In this video we are going to discuss the first 4 questions of this round. So let's get started. First question was the sequence subsequence permutation. Like in this question we are given a string and we have to determine how many we have to choose minimum k characters so we can change their order and we can sort as like if the given string is D, B and A and like D, B and A, we have to sort it. We'll want the answer like this: A, B, D. So we have to choose minimum how many characters we have to choose, so we can interchange their position and we can get the sorted string. Like this is the simple, like we can first simply sort the given string in by storing in another string and check how many characters are different from the given string. Like A is different with D and here A is different with D. Here the B is present at the correct position, so we don't have to waste any uh, operation to change the B. So answer will be 2. Like we have to check only for the operations where the characters are not at their correct place, right? So let's check for the implementation. So yeah, here I have stored string in check and I have sorted check like what we want, and if the current character in s is not equal to the check, like check is the required string, then I will increment the count and at last I will print the count, how many operation we need to sort the string, right? So let's move on to question B, running for gold. So, in this question, we are given n athletes and they have to take parts in 5 races, 5 marathons from 1 to 5, right? So, let's. So, what is the case? Like the person who like we are comparing two persons like x and y. If the rank of x is less than y for the at least 3 times, like if the current person is x, like first and second person is y, and here we can see the first person has rank 1 in first tree and second first tree, and the x is leading, like x is winning 3 times than b. So here we can say that x is superior than b. Why? Yeah. So we have to find like who will win the gold. The one who is superior to all of these will win the gold medal, right? So how we can do this question? So let like here are two very good cases. First case is this one and another case is this. Let me just copy these cases, right? Okay. First, let's erase this. Like it is a good question, like the question in this round, the problems in this round are pretty good, like good implementation problems and constructive problems. So and another one is this case, right? So okay, okay, right. So here the first, let me discuss this case. Like here let me suppose the current winner is 1, means this first person is winning, right? The first person is winning right now. So I have to check like which I will traverse to hold the n, like hold all the athletes, and I will find which one is superior to all of this, right? Like current winner is 1, so I will check with 2, like 2 is winning in this round, like 7 is less than 9, count plus plus. Here I can see that 4 is less than 5 and 1 is less than 5. Here I can see like I have find 3 ranks which is less than 1, so here right now I have the superior 2, I find 2 which is superior than 1, right? Now let's move on. Now I know that 2 is superior than 1, so I will check 3 with 2 now, because if 3 is superior than 2 then it will obvious like 3 also will be superior than 1, right? So I will in while checking, I am right now checking these two, right? 3 with 2, 7 5 is less than 7, 6 is not less than no, 3 is less than 6 and 2 is less than 8, right? Now current winner is 3, right? 3 is superior than 2 also, right? Like now 3 is superior than 2 also and 1 also, right? So here comes an plus point. So here current winner is 3. Now I will check for the 4. So 4 is no, not less than, not less than, not less than, no, none of them is less than 3, so it is not a winner. Then comes to 5. Then 5 is less. I am comparing with 5 and 3 because current winner is 3, and 4 is less than 5, 2 is less than 6, and 2 is less than 7. So yeah, here my another winner comes to 5. Now current winner is 5, right? Let's move on. Now I'm comparing 6 with 5. Now here 4 is only 4 is less than 5, right? So this can't be winner because we need at least 3 wins uh, to become superior, right? So current winner is 3. Current winner is 5, sorry. So I have to check whether is there any another athlete, like we have traversed the whole array and we find that 5 is superior. Now for the final superior we have to check again, like whether this is comparing all of these by 5, if any of these are breaking the like condition, like if till now we know that 5 is superior, if now any other person who's become superior than 5 which is not till now superior, so it breaks the violation and none of them will win the gold, and here becomes the -1 answer. Like this case comes in this question, in this test case, like yeah. So let's the current winner is 1, right? Then we check for 2, like 2 can be winner, no, only 2 of them are less than, so 2 can't be winner, right? Now check for 3, like check 3 with 1, okay, because current winner is 1. I am checking 3 with 1, I am fine 1, 2 and 3. Here now the superior become 3. Now till now our answer is 3 because 3 is winning all of these, right? But we have not sure about, like we have to check again, because we are now we will check, compare 3 with all of these whether it is really an superior, because some of might case, like some might get rejected, like this was the end case. Here it second was rejected in between. So when I am comparing 3 with everyone, so here you can see like 10 is less than 30. Let me change the color. 10 is less than 30. 10 is less than 30, and here I get okay, I have only get 2 of them superior, right? So this one is not superior than 3. So let's move on to 2. Like 20 is less than 30, 20 is less than 30, and here 10 less than 20. So now 2 becomes superior, but we know 2 is not, but 3 is superior than 2, or 3 is superior than 1, right? So but 2 is not superior than 1, so here comes in violation, like this can't, none of them can be a winner, so here is a case of -1, and here is the winner 5. So like this is the only this is what we have to implement, like this in like tricky one. So let's move on to implementation. So how I did is, like there are 5 races, so I have created an structure of like 5 races named as ABCD. So I have taken an inputs like STRI for current athlete, the first race, second race, third race, fourth, fifth, and fifth race. So the current winner is 0, like I'm moving implementing from the 0 base indexes, right? So current winner is 0. So I'm checking if the current athlete is superior than winner or not, right? If the current winner is 0, so this check function is checking, like if the current like I is the current athlete, and winner who is the current winner, right? If the current athlete has at least 3 races less than the winner, so it will become superior. So here I will change the winner to I, and in this case I am just checking whether the current winner is really superior to win a gold medal or not, right? So I will check again, if any of them become superior than the current winner, so it will like break the violation of the conditions, and we will get the answer -1. Otherwise at last we will get the winner, like winner +1, because it is an 0 base index. I have 2 + 1. So like this was a question B. Like good questions in the previous round, this round global 15. So let's move on to question C, maximize the interactions. So in this question, yeah, we are given two n districts point on a circle, right? And let me explain the question in a simpler way. Sorry, like we are given n and k, and there are two, like, n points in pairs and k points in pairs which are connected. Like, let me just draw it, like it will become very simpler to explain how to delete these images. Can I just, okay, let me just new page. Okay, if I just draw a circle, pretty good. So here isn't, like, we have 1 point, 2 point, 3 point, 4 point, 5 point, 4 point, 5 point, 6 points. Okay, 6 points, we have 6 points, right? So like in the question we are given n is equal to 3, like there are 3 points in pairs, like total 6 points, and we are given k pairs of points which are initially connected, like means they are preparing code, like let's take an example, like this is connected. Here is a feature of line here, like this is connected, and here let come, we should have connect, yes, this is connected, right? So like they are becoming a code, and we have to find n minus, we have to, we have n minus k points, like we have to join n minus k points in such a way like we can get the maximum interaction points, like current interaction points are only one, and we have to join these remaining points in such a way like we can get the maximum interaction points, right? So here is an only one way, like we can join like this, but so interaction point equal to 1. So but in the case of this one, the given case, can I draw this case also? Yeah, okay, let us draw this case. So this was the case, like 2 up and 2 in this case. Okay, ठीक है. So here comes 1 2 more, right? So here are 2 more dots, like remaining dots. So what observation like we can get? So first thing is that, like, the given codes, like we can't change them, but the remaining codes we can do something with them, so it becomes like we can, it will become easy to implement the logic, right? So 1 2 3 4 5 6 7 and 8. Okay, so what we will do, like we will store the not joined points which are not yet joined via any line. So what we will do, like there are n minus k points in pair, so we will join the first point with the n minus kth. Okay, let me draw a line only and change the color. So I will join 3 with 6 and 4 with 5, 4 with 7. So this is the case, like I am joining with 3 with 7 and 4 with 6 because, like, I am having something like this: 1 2 3 4, and I need maximum collision, like maximum interaction. So what I will do, I will join 1 with 3 and 1 with 4. I am joining the pairs, so I can get the maximum collision between them. So like I am going this way, like breaking in half, and first with, and second with this, and third with another, if there would be. So this is going like this. So like this is like a mesh topologies, like, or stars, like here we can get maximum interactions. So like, but we have to just store the given points and append the n minus k pairs by joining in such a way, like first pair with n minus kth plus first, fourth pair plus n minus kth plus second pair, like this way, like I have to join like this way, and at last the which condition which will make the interaction possible, like you can see in the question, like the constraints are very low, so n square will run easily. So we will run a brute force for every point which we have stored in an array, for the full array, full all the points which are forming a line. So what we will do, like let me take only two lines, right? Initially, like there are only two lines, 1 5 and a2. Which is the condition, like which condition make you feel this lines interact, like they will interact each other? So this is the condition when, like this is the line 1 and this is line 2. When the line 1 first pair is more than line 2 first pair, and line 2 line first second pair is more than line 1's first pair, means they are moving, coming like this way. If this is more than this one, and then this should be more than this one, like this is coming this way. And one more condition is here, that any of this point must comes under this line, right? Like this point is, if this point is 8, then this comes under 7 and 2, right? So like uh, okay, 7 and 2, yeah, like we are giving two condition, like we can check for this one and we can check for 5, because this is an like an clockwise rotation, so like they can be position like n minus 1, then comes 0, then 2. So we will check for the both the condition. So this will condition, when any of this condition meet true, we will make the count plus plus, that these lines interact and we get a point of interaction. So this is the logic we need to implement, right? So let's move on to implementation. So here, just let me zoom in. Firstly, I taken pair of vector of size k, and I have taken the inputs k, first and second. And here I did, like I have placed smaller one is first and bigger index in second, because I want to like make the logic more easy to implement, like whether this case happen 1 5 and 8 4 8 2. So while comparing in the future, so I can get 2 1 5 with 2 8, so I can just check for the second one whether it lies between 1 and 5 or not. So it makes my life easy in the future code. So, and I have taken the map to check, to store they are taken, like if there is a pair formed by 1 and 5, then I have increment the count of 1 and 5, and it is sure that 1 and 5 would make the line. Now, like I have said, we are given n and 2n pairs. So I am traversing from 1 from 2n. Any of the point which is not yet taken for to make a line, if not present in the map, so I will store them in the point point vector refers to the only the points which are not yet taken to make a line. So this is the main part where I am appending these points into the vector. So I have taken the first pointer as 0 and another at n minus k. Like total we have 2n minus k values, right? So I have taken one at 0 and another at mid. I am increasing both by every time both by 1 and making their pairs and storing them into A. Like A is an initial vector pair. So here we can get all the pairs like as z we want, so we can get a star and mesh, and so we can get the maximum interaction. And here is here I am doing like n square loop. So for every line, like for first line compare with all the other lines, second line compare with all the other lines, yeah, moving on. So here I am doing the count plus plus. So here it comes like every here is the condition. These two condition is for this line, like whether they are coming in this way or whether they are making a cross or not, right? These two condition, both of these. And the last condition is whether the third point is in between the 2 points is not, right? So this is the condition. If any of the condition makes true, and so it will increment the count, and we will print the count. It is sure that and one of these will true, not both of these at a point. So yeah, so it will not make to a wrong answer. So this is a question C. So let's move on to question D, the array differentiation. So in this question we are given an array, and we have to check whether an array B exists such that for every A there exists such B where when we choose any index j and k, their difference must be equal to a of I, right? Let me use these examples, or let me make my own example. Okay, if let me make choose this example only. 4 minus 7 1 5 10. Okay, let me clear this new page. Okay, 4 minus 7 minus 1 5 and 10. So here, like, I have to find, this is array A, and I have to find array B such that the four any two number must give the difference for every A of I need B of j minus B of j minus B of k equal to A of I, right? So I have to check whether there exists a B or not, right? So how can I check it, right? So here comes an let me take an easy, like I have to make their subset, right? So how I think to the question is like this. If I let me make my own array to make this question more easy to understand. Like I have an value 1, I have a value of 6, I have a value of 7, right? uh, okay, okay, 7. Okay, let's have this minus 1, right? It become 12. So, and here I have 4, here I have again 4, here I have 5, and here I have minus 1 again. Okay, minus 1 will repeat. Let's here I have 3, and here I have 1. So how it is, right? So I have to check whether there exists uh, B. For every A of I, there must be an two indices. If we subtract them, we will get current A of I, right? So in this array, I had taken this array in such a way like there exists such a subset where their sum is repeating, right? Like here this, like their sum is 12 and their sum is also 12. So here is a motive to do, like if if we find any subset, like not even like I let me just place over here 100 uh, 20, none of them matters, right? If I get any subset which whose sum is repeating, then I am sure that the answer is yes. Like how I'm sure, let me do this proof. So what I will do, I will make an B array such like this. I will place an 0 here, right? Like I am just what, like I get a subset pair whose sum is repeating. So what I will firstly do to make the proof more clear, I will take this array, I am place 0 here, take this array, place a 0 here, and I will just placing this full array here by making the prefix sums, right? I have take 1 here, and then I will take 5, then it will, then again 5 plus 7 become 12, right? And here I will place 4, and here I will place 8, here I will place 11, and here I will place 12. So like this, and these all are like rest of these, like we will handle and add. So by combining these pairs, and I will make b. B will become 1 0 minus 1 5 12 4 8 11, and these two pairs come here, right? So how this is generated, right? So here comes in logic, like I have, the motive is to check whether their subset sum is repeating. Is this like whenever do the prefix sums, there comes and repetition of numbers here. So we can reduce this, right? So we can cancel this and we can get n numbers, and we can definitely get an answer. I have placed a 0 here because any of the numbers is not in the this subset, so can be placed like 0. 100 minus 0 will be 100, so it is definitely true. 20 minus 0 is 20, so it is definitely true. And what about these cases? The first one is always true because minus 1 minus 0 become minus 1, and 4 minus 0 become 4 minus 0 will become 4, and it is true. What about 5? Like 5 is generated from the prefix sum, so what I will do, 5 minus 1 will become 6, and it is true. and for 7, 12 minus 5 becomes 7 and it is 2, right? Because it is, we have done the previous sums. If we again do a subtraction, we will get this number always. So what we have to do, we will just have to store the sum of every subset and check whether any subset sum is repeating. If it is repeating any, if single time only, then our answer is yes, otherwise answer is no. Because if any of subset is not repeating, we can't make an array B with the same size of A. We definitely need one extra members, like n plus, we can make n plus 1 size P. So here is a claim. So let me show my implementation for the D quotient. So what I have did is, like, let me zoom it. So first I have taken the inputs and taken a map like this. This is like finding all the subset pairs and taking the sum of each subset, and at last I am just increment the count of sum, like whether that subset sum has occurred once, so I am increment the count. And at last I am just traversing through the map, and if any subset count is more than one, like occurs 2, 3 and many number of times but more than one, so our answer is yes and we will return, otherwise the answer is no. So like this can be like a good question, like I have said in the starting, like these are the good pairs of questions. uh, we can do like good contest. So if you like the tutorial, do like and subscribe, and if you have still any doubts, you can join the Discord server or you can ask in the comments. So I will be like solving each and every doubts if you are getting in this explanation. So till then, thank you and happy coding.